Welcome to our lesson on redox reactions. Redox is short for reduction oxidation, and these reactions are fundamental in chemistry, biology, and many industrial processes. So what exactly are redox reactions? At their core, redox reactions involve the transfer of electrons from one substance to another. When a substance loses electrons, we say it has been oxidized. When a substance gains electrons, we say it has been reduced. A helpful way to remember the definitions of oxidation and reduction is the mnemonic oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. To track electron transfers in redox reactions, chemists use oxidation numbers. An oxidation number represents the charge an atom would have if the compound was composed of ions. There are several rules for assigning oxidation numbers, but here are the basic ones. Elements in their free state have an oxidation number of 0. For monatomic ions, the oxidation number equals the charge on the ion. Oxygen usually has an oxidation number of -2. Hydrogen usually has an oxidation number of +1. Let's look at an example, the reaction between iron and oxygen to form iron oxide, or rust. For iron atoms plus 3 oxygen molecules yield 2 molecules of iron 3 oxide. Let's assign oxidation numbers. Iron starts with an oxidation number of 0 because it's in its elemental form and ends with +3. Oxygen starts at 0 in O2 and ends with -2 in iron oxide. So iron loses 3 electrons, meaning it's oxidized, while oxygen gains 2 electrons, meaning it's reduced. Here, oxygen is the oxidizing agent because it causes iron to be oxidized. Iron is the reducing agent because it causes oxygen to be reduced. Here's another classic example. The reaction between zinc metal and copper sulfate solution. Zinc plus copper sulfate yields zinc sulfate plus copper. In terms of oxidation numbers, zinc goes from 0 to +2, and copper goes from +2 to 0. Zinc loses 2 electrons and is oxidized, while copper gains 2 electrons and is reduced. So copper 2+ is the oxidizing agent, and zinc is the reducing agent. Redox reactions are everywhere in our daily lives. Batteries work through redox reactions. When you use a battery, one material gets oxidized, releasing electrons that flow through the circuit to another material that gets reduced. Corrosion, like rusting, is an unwanted redox reaction where metals are oxidized by oxygen in the air, often accelerated by moisture. In our bodies, cellular respiration is a series of redox reactions where glucose is oxidized and oxygen is reduced, releasing energy for our cells. To summarize, redox reactions involve the transfer of electrons, with oxidation being the loss of electrons and reduction being the gain of electrons. Remember, oil rig, oxidation is loss, reduction is gain. Redox reactions are essential in batteries' corrosion processes and even in our own body's metabolism. By understanding these reactions, we gain insight into countless natural and technological processes around us.